Hello, everyone. You're welcome to today's class. Today we'll be considering topic that involve effective capacitance. It's a question that often comes out in external exams. Let's see what's on the board. Calculate effective capacitance between P and Q in the circuit shown below. Now, you can see that we use farad as the unit of capacitor. Okay, we have 4 microfarad in series with parallel connection of 2 microfarad with 3 microfarad and 1 microfarad. When you see capacitor being connected in parallel, you add them together. It's opposite of connections in resistor. Is that okay? In resistors, when you have in parallel connection, you find the reciprocal of each of the resistor. But under capacitor, you just add them together when they are in parallel. And also, when you have capacitor, you can see the hands, they are the same. Cell is drawn, the symbol of cell, the long hand is positive while the short hand is negative. But under capacitor, we have the same hand of equal length. Okay, now parallel connection of 2 microfarad, 3 microfarad, and 1 microfarad involve addition. Now have the equivalent, the addition of the capacitors one that in parallel, so that after getting it, you now connect it in series with the 4 microfarad. Now, uh, C parallel, that's capacitor parallel, equals 2 microfarad plus 3 microfarad plus 1 microfarad, which is which will give us 6 microfarad. Now we now connect it in series. We're having 4 microfarad in series connection with 6 microfarad. Now, since they are in series, now find reciprocal. 1 over equivalent, C equivalent equals 1 over 4 microfarad plus 1 over 6 microfarad. Or the LCM, that's 12, 12 microfarad. 4 microfarad in 12 microfarad, that's 3. 3 times 1, that is 3, plus 6 microfarad in 12 microfarad, that is 2. 2 times 1, that's 2, which will give us 5 over 12 microfarad. Equals to 5 over 12 microfarad. Now you cross multiply because we're having 1 over C equivalent to be equal to 5 over 12 microfarad. When you cross multiply, you're having 5 CEQ equals 12 microfarad. Divide both sides by 5. 5 cancel 5. We have equivalent capacitance to be 12 divided by 5. Use 5 to divide it. 5 in 12, 2. 5 times 2, 10. Subtract as 2. Put decimal, add a 0. 5 in 20, that's 4. That's 2.4 microfarad. Equivalent capacitance is 2.4 microfarad. Now let's see the connection of the second example. What is the equivalent capacitance of the four capacitors? Each of capacitance C as connected in the circuit. Let's say circuit. The circuit below. The circuit below. And see these two capacitors, they are in parallel. But why are they in parallel? When current comes, it divides. That's why they're in parallel. When current comes here, comes in, it divides. That one makes it to be these three capacitors to be in parallel. Current divides. When it comes here, current divides. These two capacitors, they're in parallel. That's the two parallel capacitor will be added together. Together, which is equals to C plus C equals 2C. Okay? Now when you add them, because they're in parallel, now the circuit will now be like this. And now in series with each other. That means that you find the reciprocal of each. 1 over C equivalent equals 1 over C plus 1 over 2C plus 1 over C. Now 1 over C equivalent equals what's the LCM? That's 2C. C goes into C, that's 2. C cancels C, that's 2. 2 times 1 is 2. 2C into C, 1. 1 times 1, 1. C into C, that's 2. 2 times 1. How is it 2? C will cancel C. Use 2 to multiply 1. That's plus 2. 1 over C equivalent capacitance, okay, equals 2 plus 1, that's 3 plus 2, that's 5. 5 over 2C. Cross multiply. Don't stop there because we only have 1 over C equivalent. We're having 5C equivalent equals 1 times 2C, that's 1 times 2C. Okay, divide both sides by 5. 5 cancel 5. Therefore, our C equivalent equals 1 times 2C, that's 2C over 5. So JAMB question comes out in external exams. Please take note. Our C equivalent or equivalent capacitance equals 2C over 5. Okay? That brings us to the end of the class. Please don't forget to subscribe to the channel for more updates. Thanks for listening. Have a wonderful day.